My name is Carlo Giacometti. I work in the sound and vision team for Wolfram. And today I will talk about video generation. My plan is to first introduce the ideas behind this, why we're doing this, what kind of targets we want to hit. And then quickly go through some of the functionality, the new functionality that can be subdivided between functionality that takes video or videos to produce another video, functionality that takes generic expressions to produce videos, exploration of 2D constructs. And as a last thing, I will quickly give an overview of what our generic plans for the future in this subfield are. So, in previous versions up to 12.3, our development was mainly focused on producing a framework to be able to perform basic operation on videos, very low level. And we can classify these as structural operations. In this case, I'm just showing trimming a video and joining a video with itself. So extremely basic operations. Hopefully we'll evaluate quickly. We have facilities to combine tracks of various kind, deleting parts of videos, replacing parts of videos. Another broad category are operations that involve processing or analysis. And one example of processing is, for example, video map that takes a video and produces frames, in this case, depending on both the frames and the audio track of the input. An example of pure analysis is using video map time series, where I can essentially map an image processing function, in this case, backed by machine learning, onto the frames of a video. In this case, I want to figure out how many cars are in each frame, and then plot the result as a number of cars as a function of time. In addition to processing and editing operations, we also introduced some functions to do very low-level video generation. And the single function that was doing this was video generator, which is a bit of an obscure function. It is not particularly user-friendly, but it provides all of the basic functionality to generate videos. In this case, I just pass it a list of images, and it will create a video with those sequence of images. But it can be much more general than that. I can just give it a pure function, as you can see here. The function is a function of the actual time in the output video. And this function produces an image per each of those times. So you can see this is a working video. But as I said before, this is a very low-level operation. So what we wanted to enable the users with was, for version 13, to have much higher level functionality to generate videos. Also with syntaxes that they are familiar and they don't have to go to so much effort in figuring out the details of. We want to make video creation easy and natural. So however you're creating your content, it should be as easy as possible to transform it into a video that then you can either embed in a notebook or share on the internet or whatever you want to do with a video. So I will start with the video-to-video category. And the first function in this category is SnippetsVideo, where the whole idea is extremely simple. We have a video as an input, and we know of a list of times that we think are important, either because we looked at the video or we ran some processing on the video, and that processing spit out a bunch of numbers. So we start on the assumption that these times are salient times. And what SnippetsVideo does is just extracts some amounts of video around these times to create kind of a summary of the initial video. By the way, I am wrapping everything in this notebook with animated image. So the outputs that you see will be actually embedded in the notebook rather than being files that live on my hard drive. And these outputs will play on your machine as well, that they are completely contained within the notebook. So hopefully that will show up. And yeah, the only thing that this did is extract some snippets around these salient times and join them together in a final video. We are also working on different algorithms for automatic detection of salient times, and that will enable us to have the snippet videos with a single argument. But yes, this is the ultimate goal of the function, where with a single argument, you can either do a random extraction, a uniform extraction, or a salient times extraction. The second function I want to show that goes from videos to video is GridVideo, where the goal is to create a collage of synchronized videos. In this case, I just give it a flat list with 2 inputs, and GridVideo will produce a single one with the 2 that are playing completely synchronized. And the nice thing is that these could have wildly different frame rates, wildly different resolutions, and GridVideo will take care of all of that and will produce something that has a sensible frame rate with which it is easy to display both of the contents. And by default, GridVideo will try to arrange a list of videos into a matrix. Here we only had 2 videos, so really having them into a matrix doesn't make sense. But for a longer list, for example, here I have 5 videos. You can see these are nicely arranged into a grid. It is also possible to control the background of this grid and the spacing. So if you want some more space between the videos, if you want to control the background, that is easily modifiable with options. And the other nice thing is if the user wants in-depth control of the positioning of a specific video in the final grid, you can input a rugged array. It doesn't need to be a rugged list. It doesn't need to be a rectangular array. This can be just a list of lists. Each list can have its own independent length. GridVideo will do something sensible and inject spacers where it thinks it is reasonable. As for these spacers, if you have opinions about where they should be, for example, you don't want it here, you want it in a completely different spot, you can control the appearance of those where they live in the grid using missing. And as you can see, this is a grid that I built, and I placed the spacer in the second row in the first position. You can also use different methods to conform the frames to the size using the conformation method option. And here we can display 3 different methods: stretching, that will deform the image; fit, that will just use whatever is available and leave some spacing on the side; and fill, that will just fill the available space. So that's GridVideo. And then the last function in the category of video to video is OverlayVideo, where the goal is to, as the name suggests, overlaying multiple videos or images onto each other. One example is a watermark. Here I have a sample video and then our beautiful spiky. And the result is exactly as you'd expect. The spiky is placed in the bottom right corner and its transparency is preserved. This overlay can also be a video, which will be synchronized to the background. I will use again my fish video that we've seen already before. Like in GridVideo, the 2 are synchronized and the proper temporal resampling is happening as well. It is also possible to overlay multiple objects, and you can also control their position using the place head. So one question is, why was the spiky in the bottom right corner rather than in the middle? Well, that's just a choice of default, right? In many cases, this will be more convenient. In many cases, it will be more convenient to have it in the center, but you can control that very finely using placed. Here, I'm placing the fish at the left bottom and the spiky at the right bottom. And you can do exactly, you can specify any scaled position here. And the two specifications here, if you, I don't know how familiar you are with placed, this will tell you where the expression will be placed in the final result. And this is the reference point in the inset expression. And this accepts a position in points or a scaled position. So it is easy to move these anywhere within the frame. As an aside, I wanted to quickly touch on a few common options for video generation that are available in all of these functionalities. So the first one is related to the encoding of the file. I will show here how to control the video encoding, but it is exactly as easy to control the audio and the subtitle encoding. Depending on your system setup, this list might be different depending on platform, how you set up FFmpeg, et cetera, But this will give me a list of what are possible encoders on essentially how we end up storing the frames into the file. And they all have different trade-offs in terms of speed and file size and fidelity to the original content, right? Because most of these will compress the content. And you can choose any of those by using the video encoding in this case, but it will be audio encoding or subtitle encoding in other cases. So you can easily choose one of the most common encodings, H.264, but you can choose more obscure ones like JPEG 2000, which incidentally will allow you to store videos with an alpha channel in most cases. At least support of it is not completely platform independent. Another very important option is the generated asset location option that will tell you where the file backing the resulting video object is stored. By default, we create automatic names. They all get stored in the user documents directory. But that can be controlled function by function and call to call. In this example, I will store the result in new file.mp4. That works. This also takes a folder. So this will be an automatically generated file name in the folder I specified. And if I want to collect all of the video generation in a single folder, I can use the generated asset location, $generated asset location variable. I can set it to a folder, and as a consequence, all of the video generating functions will produce files in that folder. Raster size option is pretty self-explanatory to control the size of the output, and most of the generating functions will are enabled to be parallelized. So, for example, this is a slow operation, the rasterization. So the generation of this video will take a little bit. But using parallelize on the video generating function, the evaluation of the function is distributed across the available kernels. So the writing to the file is still serialized. We still need to write one frame at a time, but we can chunk up the generation of the frames and distribute that to all of the kernels available. So this is a very convenient trick to know, especially for video generation that has to deal with rasterizing graphics expressions. So now pure video generation from arbitrary expression, for example, SlideShowVideo does what the name suggests, takes a list of images and displays each image for a well-defined amount of time, in this case, 1 second. And it is possible to control the duration of each image individually. In this case, we have a short first duration, slightly longer second, and very long last one. And to have more fine control over the result, it is possible to pass a time series to SlideShowVideo. And a time series object that has, in my example, images as values. And this is interesting because the time series by default will have an interpolating behavior. So I'll just chuck this into a manipulate. You can see how the images get interpolated. And by the way, this is because all of our images now support arithmetic operation. So if I pass that time series to SlideShowVideo, I inherit this very convenient interpolating behavior of time series. The second video generation function is called AnimationVideo. So the whole idea behind this was to provide much of the same functionality that Video Generator has, but packaged in a way that is much more user-friendly and much more familiar to a mathematical user. I would be really surprised if a mathematical user was not familiar on how to write a table or a manipulate, and the syntax to use AnimationVideo is exactly the same. I have a symbol that is defined onto a range and an expression that is then evaluated that depends on that symbol. So I can generate these frames and I can see, as you would expect, a constant image with varying hue. And just to compare this is, as you would expect, exactly the same syntax as you would have for manipulate. We follow the conventions of manipulate and table. So same thing. My variable rot goes from 0 to 2 pi, and I am rotating this beautiful white dog. Now we have a rotating dog. Who doesn't like a rotating dog? Just to reiterate that this is exactly like evaluating a manipulate or a table will have the exact same result. And as I said before, AnimationVideo will work with any expression that evaluates two images, but also 2 and 3D graphics, essentially anything that we can rasterize effectively. So here we have some equation that we can solve, and we can have, I think this is a Lorentz attractor, and we can have a sphere following the path determined by this Lorentz attractor. This is a nice video file now that we can export anywhere. As I said before, most of these video generator functions do accept parallelize. So it will speed up significantly the generation. Okay, now a very basic function that can be also very convenient is if we have a bunch of images in memory and we want to just drop them into a file, but not for a specific duration. We want each of the images to be a single frame of the video. FrameListVideo is the function that we want. We see we created a video with only these 3 frames, unlike SlideShowVideo that would have duplicated these frames for the specified amount of time. And the disadvantage, obviously, is that we need to store all of these files in memory. In this case, I am importing a bunch of files and writing them to disk. Now, as the last function that I want to showcase for video generation is one that does exploration of 2D constructs. This is called TourVideo. I will just give you a quick overview on what it does and some of the subtleties on which it relies. So we start with some two-dimensional construct. In this case, we have our beautiful test image. And we want to explore some details of it. And in this case, I'm just giving a list of positions specified with scale, so I don't have to figure out how many pixels there are and all those annoying things. And this will produce a video that will tour all of the points they give. So as you can see, this is moving around the image and allows us to explore various parts of it. So what are the possible things that we can explore? Well, images, as I've said, I can just find the faces in this big image, figure out the best way to pass through all of them. And then with TourVideo, I just give it the image and the list of points. And in this case, I want to go at a reasonable speed. And this will hopefully visit all of these famous physicists. Another potential input is, one question is, does TourVideo jump between position in an image or smoothly move between them? Well, it does smoothly move between them. We will implement different methods. So you will be able to control how smooth that is, or if you want abrupt jumps as well. I was saying another potential input type is two-dimensional graphics of a polygon of Italy. And here I am just collecting the points that make up that polygon. So if I evaluate that, I will slowly cycle through the border of Italy. It can also take any two-dimensional region. In this case, I have a Sierpinski mesh, and I am selecting these points here that lie on x value that is 0.5, and I can control the position, so I will tour through them, but you can see here I'm also controlling the zoom level at which I am selecting these points and the times. So here, as I said, there is more control than just passing a list of points. I am passing positions, zoom levels, and times. So the result will be something like this. So I will zoom in at each of these iterations. As I was saying, with the second argument, it is possible to specify positions, times, widths, and a rotation angle for each of the points in the path. And in this case, my path is just a spiral with increasing widths. Here we go. You can see how it is spiraling out and zooming out at the same time. And again, there is no constraint about what these points can be or should be. Anyways, so this is the overview of the existing video generating functions. And where do we want to go from now? So we want to make it easy to create contents for users that are already embedded in the Wolfram language, that know how to use them, that might need more ways to either create content from the Wolfram language to share, or create content to embed in notebooks. So the first thing that we will want to do will be expand support for primitives in TourVideo. So support for geographics and more two-dimensional constructs. The obvious extension is the same thing, really, but for three-dimensional constructs. The specification of it will be necessarily more complicated because we will have to take into account camera angles and three-dimensional paths and all of these things. But the idea behind it will be exactly the same. We might want to do morphing video, morphing between images, cinematography videos, where we take different parts of images and apply different effects, for example, like the convergence effect and stuff like that. So we want to really have a set of functionality that will make it straightforward to create video content very easily from the Wolfram language. And with that, I think that's it. And I guess you can easily imagine how this was created. Thank you very much.